As we begin this course, one of the first sections we want to look at is just reviewing some basic concepts. And we'll actually start with a word problem application. Again, in technical algebra, a lot of your technical side of your math is really about word problems, reading and comprehension, and being able to apply the math to the reading. So let's look at this first one. This would be from industry. So we have one box rivets weigh 52.6 pounds, and another box weighs 37.5 pounds. How much more does the first box of rivets weigh? So I read it through there and stuff, and notice that they're using abbreviations along with there. Notice how they have LB as the abbreviation for pounds. So, but notice how I didn't read that as LB. I read it as a symbol to represent a unit of measurement, which we call pounds. So one box rivets weighs 52 pounds and another box weighs 37.5 pounds. How much more does the first box of rivets weigh? So notice that when you read a word problem, you may have to read it a couple of times, maybe several times. I think I'm starting to pick up on what they want us to do. And notice that usually the last sentence is the most relevant one. How much more does the first box of rivets weigh? How much more? So there are some key words down here. And notice how much is in the addition symbol area. How many are there? That's kind of the same thing. So those are some, notice how many in each. So the word how much more takes a little bit more insight. It's not real clear of what that implies. So as we move further through here, our goal is to try to identify the relationship that can be used to solve the problem. And estimation can be used to better connect it. So here, to do this problem, I may want to think about this as the first box and the second box. But so what I want to do maybe say is the first, and make a little note that that's right around 50 pounds, if you will, if I'm using estimation. The second box weighs close to 40 pounds. How much more? So if I compare these two, how much more is the first box than the second box? Well, it looks like I'm saying if the first box is 40, how much more does it take to get to 50? So one way of looking at it is, 40 plus how much gets me to 50. So I kind of see that would be the first box is 10 pounds more. But as far as relationship goes, what could I do to these two numbers to get that 10? Well, notice that if I subtract these two numbers, that would give me this 10. So I'm picking up on, to solve this problem, I could be using subtraction to do this. So that's one of the things I have to first figure out is the strategy. And using estimation helps me see that the relationship of these facts is actually subtraction. So to solve this problem, I'm writing down 52.6 pounds, subtract 37.5 pounds. Now the question is, can I do this math with or without a calculator? Well, I can see that 6 minus 5 is, when you're subtracting, you want to keep the decimals lined up, so place values have to be in a line. So if I have like 6/10 of a pound, subtract 5/10 of a pound, that is subtractable. That's going to bring down a 1. But you notice how 2 1s minus 7 1s is not possible. So I can borrow from this tens place, make that 4 10s, and this 2 now becomes a 12, which allows me to go 12 minus 7 is then 5, and then 4 minus 3 would be 1. So I'm picking up on that the answer would be it weighs 15.1 more pounds. So 15.1 pounds more. So that would be kind of my critical thinking process. Now you can use your calculator to do this as well. If you're not great at doing basic math, you can just type into your calculator on your phone, if you will, 52.6 subtract 37.5 and see if that does give me, so it does give me my 15.1. So my math is good to go there. So I kind of got that problem down. So here are a list of keywords that if you want to take a picture of this and put this on your phone, if you're not great with some of the keywords in math, you can kind of do that. Just take a picture of that and just save that for you for later if you're looking for some key things to get you jump started on the problem. So on this one, it was more about me using estimation to pick up on what the problem implied. So I had to rely more on reading and comprehension to solve this problem. So I'll stop there.